Imagine a world where humanity has outgrown Earth, its resources depleted, and its environment teetering on the brink of collapse. In such a scenario, the most pressing question arises: could we find a new home among the stars? This isn't the premise of a science fiction movie but the focus of some of the most ambitious scientific endeavors of our time. The search for Earth 2.0, the perfect exoplanet that could harbor life, is not just a distant dream, it's a quest that could redefine humanity's future. Today, we'll embark on a fascinating journey to explore exoplanets, planets orbiting stars outside our solar system. We'll delve into how they're discovered, why they matter, and the groundbreaking efforts scientists are making to find a second Earth. So, buckle up as we unravel the secrets of distant worlds and their potential to become humanity's next frontier. What are exoplanets? Let's start with the basics. Exoplanets are planets that orbit stars beyond our Sun. For centuries, their existence was purely theoretical. Ancient astronomers speculated about the possibility of other worlds, but it wasn't until 1992 that we found the first confirmed exoplanet. Using radio wave data, Alexander Woolsson and Dale Frail discovered planets orbiting a pulsar, a rapidly spinning neutron star, about 2,300 light-years away. Since then, the field of exoplanet discovery has exploded. As of today, astronomers have confirmed the existence of over 5,000 exoplanets, with thousands more awaiting confirmation. These planets come in all shapes and sizes, from gas giants like Jupiter to rocky, Earth-like worlds, and even bizarre planets with diamond-like surfaces or molten lava seas. How do we find exoplanets? But how do we spot these distant worlds, often located hundreds or thousands of light-years away? Scientists rely on ingenious methods, with the most prominent being the transit method. When a planet passes in front of its host star, it causes a slight dip in the star's brightness. Sensitive telescopes like NASA's Kepler and TESS have used this technique to identify thousands of exoplanets. Another key method is the radial velocity technique, which detects the subtle wobble of a star caused by the gravitational pull of orbiting planets. This method has been instrumental in finding planets around stars too faint or distant for the transit method. Other techniques include direct imaging, where advanced telescopes capture actual images of exoplanets, and micro lensing, which exploits the gravitational bending of light predicted by Einstein's theory of relativity. What makes an exoplanet habitable? Not all exoplanets are created equal. While gas giants and scorching hot planets are fascinating, scientists are particularly interested in those located in the habitable zone, the region around a star where conditions might allow liquid water to exist. Liquid water is considered essential for life as we know it, making the habitable zone a prime target for exploration. Beyond water, other factors contribute to a planet's habitability. These include its size, atmosphere, and distance from its host star. A rocky planet like Earth, with a stable climate, a magnetic field to shield against harmful radiation, and an atmosphere capable of sustaining life, would be the holy grail of exoplanet hunting. The quest for Earth 2.0. One of the most ambitious missions to find Earth-like exoplanets is the James Webb Space Telescope, JWST, launched in 2021. Unlike any telescope before it, JWST can peer into the atmospheres of distant planets, searching for signs of water, oxygen, and even chemical markers of life, such as methane or ozone. Another exciting mission is ESA's Plato, Planetary Transits and Oscillations of Stars, set to launch in the coming years. Plato aims to find Earth-like planets around Sun-like stars in the habitable zone. Together, these missions represent humanity's best chance of finding a true Earth 2.0. Take, for instance, the discovery of Kepler 452b, often dubbed Earth's cousin. Located 1,400 light-years away, this rocky planet orbits a star similar to our Sun and lies within the habitable zone. Although slightly larger than Earth, Kepler 452b's similarities have sparked excitement about the potential for life. Another candidate, Proxima Centauri b, orbits the closest star to our solar system, just 4.24 light-years away. While its environment may be harsh due to stellar flares, its proximity makes it a prime target for future exploration. Why is this search important? The search for exoplanets is about more than curiosity. As Earth faces mounting challenges, including climate change, overpopulation, and dwindling resources, the possibility of finding a second home becomes ever more urgent. While colonizing another planet remains a distant goal, the knowledge we gain from studying exoplanets could transform our understanding of life, the universe, and our place within it. Furthermore, the search for Earth 2.0 has profound philosophical implications. Are we alone in the universe? Or could life exist on a distant world, waiting to be discovered? These questions inspire scientists and ordinary people alike, fueling a sense of wonder and a desire to explore the unknown. The challenges of finding Earth 2.0. While the quest to find Earth 2.0 is exciting, it is not without its challenges. The vast distances between stars, the limitations of our current technology, and the uncertainty of what exactly constitutes a habitable planet all present significant hurdles. But despite these obstacles, scientists are advancing with innovative solutions to tackle these challenges. One of the biggest hurdles is the distance. Even the nearest exoplanets are located light years away, far beyond the reach of current space travel. For instance, Proxima Centauri b, at 4.24 light-years, is considered close by cosmic standards, but with current technology, it would take tens of thousands of years to reach it. This means that any exploration of these planets will be limited to robotic missions, at least for the foreseeable future. Moreover, detecting exoplanets isn't a straightforward task. Planets are much dimmer than their parent stars, making it difficult to spot them. Most exoplanets discovered so far are giants like Jupiter or Saturn, whose large size makes them easier to detect. But smaller, Earth-like planets are much harder to find. This is where the power of modern telescopes comes into play. Instruments like JWST, with its advanced infrared capabilities, can detect planets that were previously invisible. However, even with these cutting-edge technologies, astronomers are still in the early stages of finding Earth-like planets in the habitable zone. Another challenge is understanding the atmospheres of exoplanets. Even with advanced telescopes, it's incredibly difficult to get a clear picture of a planet's atmosphere from such a vast distance. However, the discovery of the exoplanet K2-18b in 2015 marked a significant breakthrough. This planet is located 124 light-years away and is about 8.6 times the size of Earth. It resides in the habitable zone of its star, and recent data suggests it could have water vapor in its atmosphere, a key ingredient for life. But confirming whether a planet like K2-18b can truly support life is a challenge that requires further research. The role of artificial intelligence in exoplanet research. As we continue to search for Earth 2.0, artificial intelligence, AI, is becoming an invaluable tool. AI can help process vast amounts of data collected by telescopes and spot patterns that might otherwise be overlooked. For example, AI can be used to analyze light curves, graphs showing the brightness of a star over time, to detect subtle dips that indicate the presence of an orbiting planet. This helps scientists filter out false positives and focus on the most promising candidates. Moreover, AI can assist in modeling planetary atmospheres and predicting which conditions might allow life to thrive. By feeding AI algorithms with data from known planets, scientists can build simulations of potential exoplanets and assess their habitability. This could greatly speed up the process of identifying planets that resemble Earth. In the future, AI may even play a role in guiding autonomous space missions. As the technology for space exploration advances, AI could help navigate robotic probes to distant exoplanets, enabling us to collect data in real time. While this is still in the conceptual stage, it represents a fascinating frontier in the search for Earth-like worlds. The Fermi paradox: are we alone? As we search for Earth 2.0, we must also confront the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for it. With billions of stars in our galaxy, many of which have Earth-like planets, the question arises, why haven't we found any signs of intelligent life? Some theories attempt to explain this paradox. One possibility is that intelligent civilizations are incredibly rare and that the conditions necessary for life to evolve are far more specific than we think. Alternatively, it could be that advanced civilizations tend to self-destruct before they can become capable of interstellar communication. Another possibility is that we simply haven't been looking long enough or with the right methods. The discovery of even a single microbial life form on an exoplanet would radically change our understanding of life in the universe. It would suggest that life, at least in its simplest forms, could be more common than we think. But until that discovery is made, we must continue searching, hoping to unlock the mysteries of the cosmos. Exoplanets and the future of humanity. The search for Earth 2.0 has implications not just for science, but for the future of humanity. As Earth's population grows and its environment faces increasing strain, the idea of finding another habitable planet becomes ever more appealing. The colonization of another planet could offer humanity a new lease on life, sparing us from potential extinction. While that goal remains distant, the technologies and discoveries we make along the way could yield solutions to problems here on Earth. In the next few decades, missions like NASA's Artemis program, which aims to return humans to the Moon, and SpaceX's plans for Mars colonization, may lay the groundwork for future interplanetary travel. While Mars is often seen as humanity's first destination, the discovery of habitable exoplanets could change the trajectory of space exploration. Perhaps, someday, our descendants will look up at the night sky and realize that the stars, once distant and unreachable, now represent not just hope, but a future where humanity thrives beyond Earth. The potential of terraforming and colonizing exoplanets. While the concept of finding Earth 2.0 is tantalizing, it's not just about discovering a planet that could potentially support life. The ultimate goal would be to terraform, or make such a planet hospitable for human life. Terraforming is the process of altering a planet's environment to make it more Earth-like, typically by adding an atmosphere, controlling the temperature, and making the surface more habitable. This would involve engineering large-scale changes to a planet's atmosphere, which might include the introduction of greenhouse gases to raise temperatures, the creation of a breathable atmosphere, and the establishment of bodies of liquid water. This process, though still purely theoretical, has been the subject of much speculation and discussion in scientific communities. Mars is the most discussed candidate for terraforming, as its surface is somewhat similar to Earth's, and there are signs that liquid water once existed there. However, even Mars presents significant challenges for terraforming. The lack of a global magnetic field, low atmospheric pressure, and harsh radiation levels make the process incredibly difficult. When it comes to exoplanets, the situation becomes even more complicated. While some exoplanets are within the habitable zone of their stars, many are far too distant or inhospitable to consider colonizing in the near future. However, this doesn't mean we shouldn't explore the possibilities. The discovery of planets with potential signs of habitability opens new avenues for future research, as scientists look for planets with atmospheres that could be engineered into something more welcoming for human life. The search for alien life beyond Earth. The discovery of Earth-like exoplanets also reignites the question of whether alien life already exists elsewhere in the universe. As we search for habitable planets, we're not only looking for new homes for humanity but also for evidence of life itself. If life is found on another world, it would be one of the greatest scientific breakthroughs in history, showing that we are not alone in the cosmos. One of the most exciting possibilities is that microbial life could exist on exoplanets with conditions similar to early Earth. Some scientists speculate that, just as life on Earth began in warm, shallow oceans, alien life could thrive in similar environments on distant worlds. The discovery of biosignatures, chemical signs of life, on exoplanets would be revolutionary, confirming that life may be a common phenomenon in the universe. However, the search for extraterrestrial intelligence, SETI, takes a different approach. While discovering microbial life would be incredible, the search for intelligent alien civilizations remains one of the most profound questions we can ask. SETI scientists listen for radio signals from distant stars, hoping to detect a message from an advanced civilization. So far, we have found no definitive evidence of intelligent alien life, but the search continues. With the discovery of more exoplanets and the development of more advanced technology, the possibility of contacting another intelligent species grows. The ethical and societal implications of exoplanet colonization. As we look to the stars and dream of colonizing exoplanets, we must also consider the ethical and societal implications of such an endeavor. If humanity were to colonize another planet, we would likely be taking our own systems, cultures, and economies with us. This raises a number of ethical questions about the impact of our presence on a new world. Should we simply terraform a planet for our benefit, potentially disrupting any existing ecosystems or life forms? Should we be responsible for the environments we create, ensuring they remain sustainable for future generations? Moreover, there are social and political considerations. Who gets to go? How do we share the benefits of space exploration and colonization? The potential for inequality could be profound, with access to space resources and new planets limited to certain nations or corporations. The distribution of resources and the governance of off-world colonies will likely become major points of discussion as we move closer to actual space colonization. The future of exoplanet exploration. Looking ahead, the search for Earth 2.0 will continue to be one of the most exciting frontiers in science. New missions, like the Nancy Grace Roman Space Telescope and the Ariel mission, will build on the work of previous missions like Kepler and JWST, providing us with more detailed data on exoplanets and their potential to support life. With each discovery, we get closer to understanding whether we are alone in the universe or if other civilizations are out there waiting to be found. The future of exoplanet research will likely involve the collaboration of international space agencies, private companies, and advanced AI technologies. We may one day see the launch of missions specifically designed to visit these planets, collect data, and even explore the possibilities of colonization. As we move toward the discovery of Earth 2.0, we can't help but wonder, what will it mean for the future of humanity? Will we one day call another world home, or will we learn to better care for the one we have? The answers to these questions will shape the next great chapter in the story of our species. Conclusion: the final frontier. In conclusion, the search for exoplanets and Earth 2.0 is not just a scientific pursuit, it's a journey of discovery that speaks to humanity's deepest desires to explore, survive, and thrive. As we expand our knowledge of the cosmos and uncover the mysteries of distant worlds, we gain a greater appreciation for the fragility of our own planet. Whether or not we ever find a true Earth 2.0, the pursuit of this quest will likely bring about innovations that benefit life on Earth, offering new solutions to the challenges we face today. The question remains, will we find Earth 2.0? And if we do, what will we do when we finally arrive? The search is just beginning, and the adventure of exploring exoplanets will continue to captivate and inspire us for generations to come.